Welcome to Systems Thinking, part of our Army Design Methodology series. In this lesson, we'll explore how understanding systems, especially in complex environments, enhances our ability to frame problems, develop operational approaches, and anticipate change. This perspective is foundational for strategic decision-making in today's multi-domain operations. As we begin to explore systems thinking, it's critical to understand the urban environment as our operating context. ATP 3.06 describes urban areas as a dynamic system of systems made up of people, terrain, and infrastructure, what we call the urban triad. These components interact constantly and unpredictably, creating unique challenges for commanders. FM 3.0 introduces the idea of multi-domain operations, where joint and Army capabilities are integrated across land, air, sea, space, and cyberspace. When we apply this concept to an urban setting, the complexity multiplies. The convergence of domains within the dense, layered systems of a city demands a different approach, one that goes beyond linear cause and effect. That's where systems thinking comes in. A system is more than just a collection of parts. It's a purpose-driven whole, shaped by how its elements interact. Systems thinking helps us move beyond linear problem-solving by examining those interactions, both internally and with the environment. In complex operational environments, this mindset allows commanders to see problems not in isolation, but as interrelated components within a system of systems. Every system exists within a hierarchy. The system we choose to study, our observed system, is influenced by a larger supersystem, and it contains multiple subsystems within it. This hierarchy shapes purpose, behavior, and influence. In urban operations, recognizing where we focus, city, neighborhood, or regional context, helps clarify both problem framing and intervention points. In complex environments like cities, problem sets rarely come neatly packaged. That's why we start with divergent thinking, using brainstorming to surface a wide range of variables, actors, and tensions without trying to categorize them yet. Here, you see a sample brainstorm pulled from real-world urban contexts. Gang taxes, failing infrastructure, migrant influx, protests, street vendors, riots, etc. These aren't isolated problems. They're interdependent touchpoints that signal broader systems at work. At this stage, the goal is volume over precision. We're building a map of complexity, not filtering for solutions. After brainstorming, we shift to mind mapping, an organizing technique that helps us move from scattered observations to structured understanding. Here, we begin clustering related variables into categories like governance, security, flows, services, and informal systems. This visual grouping helps the team identify how these elements interact. For example, how disruptions in fuel delivery might affect health services, or how informal economies bypass official governance structures. According to ATP 5.0.1, mind mapping supports the creation of system narratives and prepares us to identify key points of tension, leverage, or vulnerability within the urban environment. This model visualizes an urban environment as a system of systems. Each blue node is a functional domain, like flows, governance, or security, while green nodes represent actors or variables. The dotted rings suggest each node could be its own system. Red lines highlight tensions across systems. As ATP 5.0.1 notes, understanding these interdependencies helps us anticipate how actions ripple through the environment. Urban environments are defined by dynamic, overlapping systems, people, terrain, and infrastructure all interacting in unpredictable ways. As ATP 3.06 describes, this creates an interdependent system of systems. Understanding this complexity isn't optional. It's essential to identifying opportunities, anticipating cascading effects, and shaping outcomes in the operational environment. According to ATP 3.06, a system is a set of interdependent elements that form a unified whole. These systems, physical, functional, or behavioral, are dynamic. Their flows of resources or commodities shift based on civil or military influence. This sets the foundation for understanding how stability or disruption emerges in urban environments. Simple systems are straightforward and predictable. They operate as closed systems, with relatively few components and limited interaction between parts. Each element has a clear, traceable role, like the power grid example here, where electricity moves in a linear path from generation to consumption. While simple systems are useful for illustrating basic relationships, they don't reflect the complexity of real-world operational environments. Still, understanding them helps set the foundation for recognizing how much more complicated things become in urban adaptive systems. Complicated systems differ from simple ones in scale and structure. While still closed and engineered for predictability, they involve many interdependent parts, each with a specific function. Urban governance is a good example. Education, waste, emergency services, and healthcare all operate independently, but they are also deliberately integrated through policy, infrastructure, and collaborative planning. Like the systems on a submarine or the International Space Station, complicated systems require expertise to manage, but with enough analysis, their interactions are knowable. They are intricate, but they are not chaotic. This slide captures the essence of a complex system: open, adaptive, and unpredictable. Urban environments are made up of countless interrelated parts: land, people, infrastructure, media, and time. These elements don't just coexist. They influence and reshape one another in ways that often defy logic. As Kleiman explains, even small changes can ripple unpredictably through the system, producing outcomes that aren't always intuitive. That's why systems thinking is essential for urban operations. Without it, we risk applying linear solutions to problems that are anything but linear. This coin dynamics map from Afghanistan illustrates a live example of complexity. Each node and arrow reflects dynamic relationships between insurgents, governance, popular support, and external actors. As ATP 50.1 emphasizes, understanding these interdependencies is key to identifying leverage points and anticipating unintended consequences in operations. Complex systems operate across boundaries, filled with independent actors, feedback loops, and adaptive behaviors. These systems blend the simple, complicated, and complex. They evolve, often unpredictably, and exhibit emergent outcomes. This is why understanding the structure alone isn't enough. We must study how the system behaves over time. In urban operations, people are not just part of the environment, they are the objective. ATP 306 emphasizes that contests of human will are central to city conflict. Understanding people systems means examining local power dynamics, how groups are organized and interact, and how corruption shapes influence. These human networks are dynamic and deeply embedded, making them essential to any system-based analysis of the urban environment. In the urban triad, terrain is more than just ground. It's a multidimensional system that includes surface, subsurface, supersurface, airspace, and maritime space. According to ATP 306, each of these layers influences how forces move, communicate, and gain advantage. Terrain systems include everything from building height and city layout to underground tunnels, ports, and electromagnetic networks. These elements shape how we visualize key terrain, assess mobility corridors, and control access points. Understanding terrain as a system helps commanders anticipate how urban infrastructure either enables or constrains operations. Infrastructure is the physical and functional backbone of the city. According to ATP 306, urban infrastructure includes 6 categories: economics, administration, energy, culture, communications, and transportation. Each contains hundreds of subsystems. When one fails, like water, power, or roads, the effects ripple through the rest. Understanding this system of systems helps us anticipate cascading impacts across the operational environment. This concludes our session on systems thinking. As you've seen, urban environments operate as dynamic systems of systems. To navigate complexity, planners must think critically, embrace ambiguity, and draw from doctrinal tools like ATP 5.0.1 and ATP 3.06. These references will support your continued learning and application in real-world missions.